Okay, so part A says find the average rate of change. Hopefully you remember that that just really means the mean value theorem. Okay, so average rate of change. So, and we're going from 0 to pi. So we're just going to do f of pi minus f of 0 over pi minus 0. And we're going to work that out. Now, f of pi, just remember, pi is 180, and you're going to put that in here, into that equation. All right, so we're going to do e to the pi times the cosine of pi. And the cosine of pi is -1 minus f of 0. So that's e to the 0, which we really know is 1, times the cosine of 0. And the cosine of 0 is 1. And that's all going to be over pi. So then if we keep working that out, that's going to be negative e to the pi minus 1 over pi. And there's your answer. Part B is asking for the slope of the line. All they want is the slope of the line tangent to the graph of f. So here's f. If we want slope, you should be thinking the derivative. Okay, so I'm going to do product rule. So the first times the derivative of the second plus the second times the derivative of the first. Okay. All right, then what do they want this at? They want it at 3 pi over 2. So I am looking for f prime of 3 pi over 2. Now remember, 3 pi over 2 is really 270 degrees. So I want e of 3 pi over 2, which there's no way I'm going to know what that is, but that's okay, times negative sine of 3 pi over 2 plus, I'm going to put that e to the x in front, so e to the 3 pi over 2 times the cosine of 3 pi over 2. All right, so, well, let's look at what we have here. The sine of 3 pi over 2. What's the sine of 3 pi over 2? That should be -1. But times this negative is going to make it +1. So then all we have there is just e to the 3 pi over 2 plus. All right, then we have e to the 3 pi over 2 again. And what's the cosine of 3 pi over 2? And the cosine of 3 pi over 2 is 0. So that will cancel that out. And our answer is e to the 3 pi over 2. All right, so they want us to find the absolute minimum value. So I see this word right here. That's the first thing that jumps out at me. And minimum, you should be thinking derivative. Well, we have the derivative. We have the derivative from part B. So there's my derivative from part B. And remember, usually if we want to find a minimum or a maximum for that matter, we would take the derivative and what will be the next thing that we would do to that? Wouldn't we take that and then just set it equal to 0? Okay, now I noticed something here. I'm going to try to make your life a little bit easier anyway. I noticed there's an e to the x here and there's an e to the x here. It will make our life easier, you'll see why in a minute, to factor that out. So let's keep this, okay, and I'm going to factor out that e to the x, which is going to leave me with negative sine x and then plus cosine x, right? And that's going to equal 0. Okay, so I'm hoping that you're starting to see why I just factored out that e to the x. We're trying to figure out where this derivative is going to equal 0. Well, I have two factors, this and this. Think about that now. What have I told you many times about e to the x? Okay, remember what that graph looks like. It looks like this. It's never going to equal 0. So this never will equal 0. So when we're trying to set our derivative equal to 0, I can ignore that factor because it never will equal 0. So then basically, I'm just going to look at where, And I'm going to move that sign x, that negative sign x, to the other side of the equal sign. So really, I'm looking for where the cosine and the sine are the same. Okay, so now let's think about that. What angle measure is the sine and the cosine the same? And that should be 45 degrees, right? Okay, I'll put it in degree form for you for now, and also 225 degrees, because in the third quadrant, sine and cosine are both negative, so they would have the same value. Okay, so for 45 degrees, we can't write it as that, so that's pi over 4. And then 225 degrees is 5 pi over 4. All right, so the next thing that the question, I'm going to go back to the question, it says to find the absolute minimum value. Okay, so first of all, value, remember what that means. That means we want to find the y value. And we want the absolute minimum, so the absolute smallest value that we can get. So you have critical points right here. You have pi over 4, that's one of them. You have 5 pi over 4, that's the other. But don't forget you have an interval here. So you have that endpoint and you have that endpoint as well. And remember, if we want to find a y value, where do we plug all those 4 critical points that I just pointed out? Where do we plug those in to find the value? And I hope that you're saying that we would plug it back into the original function, into f of x. So sometimes what I like to do, and I think it might work pretty well in this case, so let's do this. I'm going to make a chart. Okay, so over here I'm going to list the x values, and then over here we're going to list the f of x values, and whichever f of x value is the lowest is the answer. So I have 0. We know we've got, pi over 4. I don't know what's going on with my pen. Let's do this. I have 5 pi over 4. And the last one that I have is 2 pi, right? Okay, so we're going to put these back into the original function, and we're going to work that out. All right, so I've got e to the 0 times the cosine of 0. Okay, so then here I have e to the pi over 4 times the cosine of pi over 4. Then here I have e to the 5 pi over 4 times the cosine of 5 pi over 4. And then lastly, I have e to the 2 pi times the cosine of 2 pi. Now I have to work all this out. Okay, so let's just extend this out and let's see what we get. All right, so what is the cosine of 0 here? Well, the cosine of 0 is 1. So then, so then what I have here, let me use my little pointer. So I know that this is 1, and anything to the 0 power is also 1. So that value is just 1. Okay. All right, let's look at the next one. Well, I don't know what e to the pi over 4 is. I have no idea. So I know that that's e to the pi over 4, and then it's going to be multiplied by the cosine of pi over 4. Okay? And the cosine of pi over 4 is radical 2 over 2. All right, let's go to the next one. Again, I have no idea what e to the 5 pi over 4 is. But I should know what the cosine of 5 pi over 4 is, which is 225, right? Well, if the cosine of pi over 4 is radical 2 over 2, then the cosine of 5 pi over 4 is also going to be radical 2 over 2. But it's in the third quadrant, so that's going to negate that value. Okay, so this is going to be negative radical 2 over 2. All right, and lastly, e to the 2 pi times the cosine of 2 pi, and the cosine of 2 pi is equivalent to the cosine of 0, which is 1. Okay, now again, let's go back and read the question one last time. It says find the absolute minimum value. So we want the lowest value. Okay, well listen, we don't really need to know very much, but look right here at this. This is the only value out of all 4 of them that's negative. So this value is the absolute minimum value, okay? Because it's the only one that's negative. It's got to be the lowest one. So this would be your answer. All right, just remember back to when we first started limits. The very first thing that we would do is we would just take the value that it was approaching, which in this case is pi over 2, right? And wouldn't we plug it in here and here? Okay, well, that's exactly what we're going to do. So I'm going to find f of pi over 2 over g of pi over 2. All right, well, first things first, I noticed that in part D, it says right here, here it is, that g prime of 2 is 0. So, I'm sorry, not g prime, g of pi over 2 is 0. My fault. So that means this is 0, right? And now I'm going to find f of pi over 2. Okay, well, think back to the formula for f, and that's e to the x, it's at the top of your page, times the cosine of x. Okay, that's your f of x, right? All right, so we're just going to plug in pi over 2 there. So that's e to the pi over 2 times the cosine of pi over 2. Well, what's the cosine of pi over 2? Isn't that 0? So then 0 times e to the pi over 2 will be 0. Now, what do we call that when that's 0 over 0? Do you remember that's called an indeterminate? So if we end up with 0 over 0, we can do L'Hopital's rule. We did that right before school let out. So all you do is keep the limit as x approaches pi over 2. But now what we're going to do, oops, that should be a 2. We're going to take the derivative of the top, and we're going to take the derivative of the bottom. So then we're going to be doing f prime of pi over 2, and then we're going to do g prime of pi over 2. Okay, well, now let's look at, I don't know why I'm drawn to the denominator first, but g prime of pi over 2, this is the graph of g prime. So I could go straight to pi over 2, follow it up, and there's its value. So g prime of pi over 2 is going to be 2. Okay, now we need f prime of pi over 2, which means let's go back to what f prime was, and we did that in part B. We also did it in part C. I'm actually going to go to the part C one, and I'm going to write it over here on the left. So the derivative, remember I factored out the e to the x? I like doing it that way. It's a little bit easier. And then I had cosine x minus sine x. And again, this is the derivative. Okay, so this is f prime. Okay, so I'm going to plug in pi over 2. So that's going to give me e to the pi over 2, right, times. Okay, so then I am going to put in, right here, I'm going to put in the cosine of pi over 2, and then I'm going to do the sine of pi over 2. So what's the cosine of pi over 2? And that's 0, minus the sine of pi over 2, which is 1. All right? So then, really, what I have here, then I'm just going to carry this on down here. So that limit as x approaches pi over 2 is going to be e to the pi over 2, but this is going to be -1, right? So I'm just going to stick a negative right in front of there, and then it'll be over 2. And there's your answer.